Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review how to use calculus to solve problems involving displacement, velocity, and acceleration. Kinematics is just a broad term for all of these. So, displacement is similar to distance, velocity is similar to speed, except displacement and velocity are known as vector quantities because displacement and velocity, they have both magnitude, size, and direction. So because displacement and velocity both have direction, they can be negative. Acceleration can also be negative. When they're negative, it just means things are happening in the opposite direction. For example, a velocity of positive 10 meters per second might mean you're going to the right. A velocity of negative 10 meters per second means you're going to the left. That negative is just a direction sign. So remember, velocity is just the rate of change of displacement. You know this from speed and distance. Speed is just the rate of change of distance with respect to time. How quickly distance is changing with time. Velocity is just how quickly displacement is changing with time. And we know that rates of change, that's exactly what the first derivative is. So velocity is the first derivative of displacement. Acceleration is the first derivative of velocity. In other words, if you have displacement, you differentiate once to get velocity, and you differentiate twice to get acceleration. We just need to be a little careful here because we're used to differentiating things that are y equals, but for displacement, we normally use x because we're talking about objects moving in a straight line like this. So x is displacement, v for velocity is x dash, first derivative of displacement, and a for acceleration is the second derivative of displacement. All right, let's use all this to solve this problem down here. So the displacement of a car traveling in a straight line is given by this function here. X is the number of meters from the starting point after t seconds. And we're going to answer all these questions here. First, let's just have a look at what's going on. So if I were to graph this function here, it would look like this. And no, I haven't made a mistake. X is supposed to be on the vertical axis because it's x equals something. So x is like replacing y and t is like replacing x. Okay, so this function looks like this, but the car isn't like going up and then coming down. The car's actually traveling in a straight line. What's actually happening is the car is going like in this direction, and then it stops, turns around, and comes back in the other direction. The car is traveling in a straight line. This is not the path or the trajectory the car takes. It's just a function that allows us to read off the displacement at a given time. For example, if I substitute in t equals 2 into this formula, I get x equals 32. So after 2 seconds, the car is 32 meters from its starting point. Even though this isn't the path it's taking, the car is going in a straight line like this. All right, let's actually answer the questions. How fast is the car traveling after 4 seconds? So how fast? We're asking velocity. So to find the velocity, we need to differentiate the displacement. So hopefully you remember, if we're going to differentiate this function here, first principles, that would take too long. We differentiate term by term. So we differentiate 20t is just 20. And remember, we're using the rule of we move the power to the front and decrease the power by 1. So I move the 2 to the front, minus 2 times 2 is minus 4, and I decrease the power by 1. So it's minus 4t or 4t to the power 1. So this is a function from which we can find the velocity. So the answer to question A, how fast we're traveling after 4 seconds, all I need to do is substitute t equals 4 into this function here. So it would be 20 minus 4 times 4, which equals 4. Now, because we were told that this is meters and seconds, our velocity is 4 meters per second. All right, to find the acceleration, we take the velocity and we differentiate it. So the second derivative of the displacement, which is the derivative of the derivative. To differentiate this, remember the derivative of a constant is 0. The constants just vanish when you differentiate. And to differentiate minus 4t, I just get minus 4. So the acceleration is minus 4, and we write it as meters per second squared. So here the acceleration is constant, and it's negative, which means the car is slowing down. The velocity is decreasing. All right, so the final part to the question says, how long will it take the car to stop? Well, the car will stop when the velocity is equal to 0, because then it's not actually traveling. So if the velocity equals 0, that means this here equals 0. So if 20 minus 4t equals 0, you know how to solve this. Just subtract 20 from both sides, divide by minus 4, you get t equals 5. And remember, t is in seconds. So the car will stop after 5 seconds. So the car is traveling. It starts at 20 meters per second. Its speed is decreasing, decreasing, decreasing. After 5 seconds, the car stops, and then it actually turns around and goes back towards where it started. So it goes like this. Speed is decreasing, stops, then it moves in the other direction like that. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.